Hello, this is Dan, and I'm back in Godot. And I've gone back to my sound test little project environment, and I've added a little bit. This was in my first video where I had, basically just showing how to make the faders for the music and this funny tuba sound, how to make that work. So I've added this new thing, and before I show you what that does, it's basically just it's just going to play back a hi-hat. And so I want to thank Cyber Reality and Megalomaniac from the Godot forums. It's a great community, it seems. I'm pretty new to it, but the responsiveness I'm getting is really heartening. It feels like I'm not alone trying to, get good at using this programmatic. So anyway, I've just set this up. I just have this. This is from the second video, the last video, just kind of similar stuff I've used to start and stop a drum machine. And so here, instead of using timers, because they seemed a little unstable, it was suggested I try using the physics process engine, or rather just the physics process. And basically, this function is called every time the physics processor iterates. And no joke, I planned on doing that because it's the next thing to see if we can get more stable sound or more stable clock, so that the hits are just more precise. And let me also just say that finding an odd bird of a drum machine that has kind of like weird deviations is not a bad thing. It could be very nice to have a nice tool to have just like kind of a slightly deviated, kind of goofy sound. I'm not against that at all. And in my music production, I may end up using something like this. But anyway, here is that physics process thing. So anyway, every it's 4 times a second that is what this. And also thanks to Cyber Reality for recommending the modulus function. This is just a quick way of doing this in one line of code. And that's basically just what this math works out to. 3000 is the dividend you want to use for eighth notes when you're using this formula. So let's take a listen to it. Oh, and by the way, this is dependent on this setting here. Now, Cyber Reality recommended using, okay, so here's the physics thing, using 1000, but I'll show you in a minute why I'm using 100 instead. The math works out just fine. Instead of, like if you're using 1000, theoretically, you would use 30,000 as your dividend, but with 100 and a dividend of 3,000, it's just fine. All right, so that's what we hear. And you can already hear, it sounds kind of similar to the timer. And if you go faster, you can kind of hear it even more, how it's just kind of goofy. It's not like computery, super solid computer clock like you'd get on most drum machines. Again, kind of like that. It might be fun. One thing that this does take care of, if you watch the last video, using the timers, if you go really low and then high again, I had to like make it so that every time you moved the tempo control, it would sort of pause while you're moving it. It would pause the playback to basically, because when you bring it all the way down, it would set the timer to really, 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 really low, and then you'd move back up, and then until that timer ran out, you'd just have silence, so it'd feel like broken. And so that was my fix. So this gets rid of that problem, which is nice. But we still have kind of the weird sort of goofy clock going on. And it's understandable, this clock we have inside the engine is not made to do this sort of thing. It's made to process graphics and basically just make a game. Completely understandable. Honestly, it's what I expected anyway. So, I'm still looking, for a solution to this. And I think I found something. And, first, I wanted to show you why I'm not using 1,000. So let me change to 1,000 over here. So theoretically, this should process the physics delta 1,000 times a second. We multiply our dividend there by 10. And what do we get? It's not working. It went slower. And that's about as fast as we can get. So what does this tell us? Well, this tells us that there's a limit to what we can process, how quickly Godot can process. And 1,000 times a second is not anything. You wouldn't want that anyway, I think. I think it's good that they cap it. They cap it somewhere around 500, I think. Oh, and I don't want to forget, there's one other thing I want to show. So now I've put it around 500, and this should be, if it's capped at, I'm not sure if it's capped at 500, but this should be 120. And actually, I have a metronome right here. All right, so I'm going to let go of it and try and sync this up. All right, so this is slower. So the actual cap is below 500. So what I'm going to do is just set this back to 3,000. And I wanted to show really quickly that, while the hits are somewhat inaccurate, the clock, the actual physics process is still chasing. It's chasing a real solid clock. It's in I don't know, that's kind of the term I use, chasing, because in music production and music technology, that's kind of a term you would use for that sort of thing. I'm not sure if you use that in computer science. But anyway, so this is back to where we were. This should be a pretty solid 120. And let's see if I can sync it up. So you can hear that some of the hits are off. But overall, it's sticking to the tempo, which is important, because any sort of beats that you would make in a drum machine built on this design can still sync up over time. And you have these inconsistencies, and again, sometimes these inconsistencies are very nice to have in a tune. There's a function in a lot of music production programs, aka DAWs or digital audio workstations, that try and make that happen. They kind of add random nature to otherwise robotic hits. So it's a thing. It is what it is. So anyway, let's move over to my actual drum machine project. And I will talk really quickly about another idea I had. And so I'm going to this one because it's timer based, this possible solution that I have. So anyway, let's just show you, I'll show you my process, and hopefully this won't take me too long and I won't get too confused while I'm doing it. So I'm actually going to add this tempo variable just for the moment at 120, which is just a standard tempo, good standard tempo to use in music software. Is it not like that? tempo 1. Why doesn't it like that? Oh, because somehow that got put there. Yes. Must have hit something. All right, so we have that. Now, if we revisit this, and again, I'll play it back, and there's stuff added to this. So actually, I'm not going to play it back just yet. After I describe this, I'll show the new stuff that I add to this, and I think I'll add one more level of functionality at this point. So anyway, what the thing that is making this work, I'm using a while loop, and then at the end of everything playing, this timer is sort of pausing the function before it moves on. And the length of the timer, the wait time is the name of the variable. The length of that is, and you can see down here, this is where I control it, the wait time. The length of that is what is controlling the tempo of our drum machine. And I will just play back. As you can see, I added this, and then there's this goofy thing that is not functional right now, but it's there. So, as you can see, there's that pause there while you're moving it. Oh yeah, and I added the stylus, which is just the Godot thing. So that's new. And this hi-hat. I've also added this hi-hat. But we'll go over that in a moment. What I want to talk about here, just because this regards the forum topic, is I'm going to change this. I'm going to comment this stuff out for now. And instead, what I'm going to do is use an OS call. I'm going to call the OS because I looked in the OS, and there's things I've called from there. There's a function in there called wait. You delay, or it's os.delay milliseconds. There's also microseconds, but that's a little too precise for us. So my idea here was to basically create eighth notes this way, because that divided by tempo, because it's milliseconds, that means there's 1,000 every second. So our dividend to get eighth notes is 30,000. And so down here on our tempo control, I'm going to comment out this, and I'm going to comment out this. And then I'll just set tempo to the value being sent by the tempo slider. Now, this is just the process I went through. And as you'll see, when I hit play and start the function to play, seems to work. Why is that? No, it is working. And it sounds solid. It's very, very solid. But it instantly breaks the program. So basically what we're dealing with here, and just to show you, I'll just set a few different tempos. So 200, which is pretty fast. So what we have here is a very solid clock, because it's not looking at Godot. It's actually looking at a higher up or lower down, a lower level timer. And so we're not getting those inconsistencies. Unfortunately, my program doesn't like this. And perhaps someone with some more experience can help me with that. Let me see if I can get this to close. So anyway, that seems to be sort of the solution to get a much more solid clock. So I'm just going to set it to tempo. So it's just delay. Everything is delayed by 120. I'm not sure exactly what the BPM translation would be, but I was actually having a hard time putting variables in this when I tested it. That's why I was a little surprised. But that's actually awesome that it will accept variables. I don't know exactly what I did differently. But anyway, let's get back to where we were. So essentially, I have a solution. I just need to find a way to implement it so that it doesn't crash the program in the runtime. So that's really, really heartening. But I do like my odd little bird here. So if we go down and look at things I've added, so I've added these hi-hats. I added both the closed hat and the open hat. And I've done something with those that is you see it in a lot of drum machines, which is called, I've made it into a choke group. And let me see if I can find where that is. Oh, actually, I've hard coded it in the playback. So anyway, and actually I wanted to update this a little bit. So whenever the closed hat plays, it stops the open hat. And whenever the open hat plays, it stops the closed hat. And that's what the idea of the choke group is. Now, this can be implemented differently, but I'm doing it like this. Like, basically, you could have a little button, let's say for each track, let's say, and that adds it to a choke group. You could have different choke groups, and that functionality can be coded. As far as my UI goes, I don't want to be putting a lot more buttons because I want to add other cool stuff. I know that I want these hi-hats on a choke group. And I will actually just show you why. And it may not be super apparent. I'll do my best to sort of show. So I've commented out the choke functionality. So now let's just I'll show you. I'm going to turn these off. It takes a second. And actually, let's just have it like this. All right. So the choke group is currently off. And let's listen to it. If I turn it up. So what we're hearing is just the sample, the open hi-hat. I want you to particularly listen to the open hi-hat. Now, even though this is drum machines are meant to sort of give you what would actually be happening on someone playing a kit. And a hi-hat works, the way a real hi-hat works is that the player's foot, their left foot if they're right-handed, is on a pedal that actually clamps the two cymbals together, and you get the closed hi-hat sound, which is like that. And then if they lift their foot up, you get the open sound, which is like this. And it sort of lasts a little while. It has a longer envelope, is the way we would call it. And then, so they will go back and forth. And actually, let's just make it really obvious. They will go, like in a disco beat, they will go closed, open, like do. And when you're doing this, the hi-hat, when it closes, this open note does not ring out. So that's a reason that we one of the main reasons we use choke groups. So again, let me see how quickly I can do this. Let's just like, all right, so that sounds like that. And then try and keep that in your mind. I will add them to the choke group. And it sounds like this. So the open symbol is stopping as soon as it closes. And I do have the choke group, I do have this stopping too, the close hat. Even though it's so short, it shouldn't matter. But in a case where, let's say if you're going just very fast, they may interact with each other. So basically it's a way to prevent two sounds from playing at the same time. So that's the choke group. This stylus right here is very useful, obviously. And you can use, obviously, whatever you want. And there's lots of ways to do this. The way I've implemented this, let me see if I can find this. And, you know, there's probably way, way better ways you could do this with fewer lines of code. I've used a case. Here we go. So this I've done within the process node, and I've just done this in a different node. I put it in the process node instead of the physics process node, but whatever. So this is where we have the update of these things, and I think that there is a function just update that will allow this to work. That I don't like. I could take all this out and just use a function called update. Not 100% sure, but I may just try that. I don't want to change it right now while I'm doing this video. But anyway, so we have this case thing, which in Godot uses match. In other programming languages, use the switch keyword. And basically, it just sets the stylus X position depending on what our time variable, which is X, is at the moment. So that, you know, works pretty well. It's kind of a lot of lines of code, but, you know, not a lot going on. So no big deal, I think. Let me know if you got a more elegant suggestion for how to do that. And then obviously I've added reverb controls. And if we go to our audio setup here, I have this. And whenever you add an effect, so there's all these effects here, and I've added reverb. Whenever you add an effect, you have all of these controls, and there's actually a second set right here, which are very useful. And so basically all I've done is add all of these sliders and these labels for the sliders and set them up basically. So wet, dry, let's take a look at that one. So there are actually two controls here. A lot of reverbs have a mix control, a wet, dry control just on one. And that's a compound control. And as you can see, our wet, both of these are set from zero to 1. They're floating values, and 0 is nothing, 1 is 100%. And these are inverse ganged, as we would call them in audio engineering, in that when wet is 0, dry is 1, and then we take the value of the slider and we subtract it from dry while we add it to wet. And that's what we call inverse ganged faders. And so that just controls how much reverb is on going to the bus. So it's low, we have a little bit, we up it. And now when it's all the way up, we have 100% wet. And it's a little loud, so there's like adjustments we can make where like perhaps we would want to have this be like limit how high we can go with the wet. So like bring the dry down all the way, but limit how much wet we can have. So maybe minus 0.2. And let's see if that improves our results. Well, that's actually kind of bugged us out a little bit. And I wonder why. Let's see. Why would that bug us out? That would put us below 0, I guess, on this. But anyway, let's leave it how it was and just talk a little bit about this function again. If you watched the last video, you know that, and the one before that, you know, we call our audio server kind of like we called the OS, but we call the audio server, and there's the function get bus effect, and we have to give it the bus, and this is our master bus, so it's bus 0, and it's the first effect on here, so it's effect 0, and we can just, if we highlight this in the inspector, the effect, we can see all the different variables we can get. So even though these are located lower here, I think this is the most important one. So on my drum machine, I wanted to have it first from the left, and it works pretty well. The high pass, second most important in my opinion. I'll play that. And this one is just one value. And it's important, here, let's take a look. Reverb high pass slider. It's important to have these values set correctly on our sliders. So, and then also, you know, because I have, it's the value is 0 to 1, and on the slider, I just had it set up for integers really quick, so I just divide by 100. No big deal. So we'll add some reverb, and we'll use the high pass. So that's basically what we call a filter. It's a high pass filter, so when it's off, we can hear all the low end, and when we bring it up, start to just hear, on the reverb, you just hear the really high stuff. So just the slap of the snare drum and the hi-hat. So we saw that, and let's check out what the size does. Actually, I'm going to leave this around here, because that low end's pretty wild, especially when we bring the size up. So this type of control on different reverbs does different stuff mathematically. And yeah, so we'll leave it high just so we can hear what these other things. Damping. Now damping is much like the high pass filter, but it does it on the high side of things. So as we bring it down, we're going to get a darker sound. And again, that's not true of all reverbs. Sometimes damping does different stuff. We'll bring the size down, and we'll talk about our pre-delay. You can kind of hear there's like an echo in the delay. And when we bring this down, that kind of gets rid of it. And when we bring it up, we can really hear a lot of what's called pre-delay. And then the feedback control just does... Now, this is very different from what you would find in a lot of more standard reverbs. I like this reverb. It's fun. It's a fun effect. But yeah, it definitely has some fun, weird stuff happening. Kind of funky. And you could really get some wild effects. I'm going to bring down the volume a little bit. And you could just get it to start going nuts on its own. So that's kind of fun. Let's really quickly just add, before we finish this, I'm going to add another effect. And let's see, I'm going to add a chorus. How about? We'll see how this chorus sounds. So, actually, so this is what I call the macro ball. That is for the future. I should just get rid of it for now. I'm going to go ahead and just make another slider. Grab it. Grab the feedback slider. Duplicate it. And place it there. And let's take a look at our chorus effect. Voice count, dry, and wet. So let's make another dry wet control. How about? Okay. I'm just going to call it chorus. You could also, I guess you could call it mix. Chorus mix. And we'll move it over. I won't label it just yet. I probably won't. I'll just not label it right now in this video. Set the value, initial value to 0. And in our scripting, oh, and actually there's a signal there, so we'll get rid of the signal. And then reconnect the signal. This is just my workflow. There might be better ways to do this, but I find that's just fine. So right here, we're making a ganged fader, and we've already done that. So let's grab that and bring it in. And everything should be the same, except that instead of effect 1, we're doing effect 2. So that should do it. And the chorus effect is kind of like a modulaty effect, whooshy whooshy sound. Let's see what it sounds like in Godot. I've never actually used it. That's cool. I like it. I like it a lot. And it's coming, so it's also located after our reverb. So it's affecting the tail of our reverb, which is kind of nice. And just for fun, let's go back to our chorus and just, I don't know what this is limited to, but let's try 100. Oh, 4. 4 is the max. That's much more sane. It's a much more sane level. So yeah. Chorus is a delay effect. It's a modulated delay effect. And it's interesting, this is such a simple chorus. It's just dry, wet, and voice numbers. That's just pure wet. And actually you get more of an effect with this, I think, when you're down here. You get more of a phasey effect down here. What you call comb filtering. And then up here, again, the wet is a little bit more amplified. So I'd like to find a way, just some easy math to prevent it from going below 0. I'm sure that's just an easy thing, but I just don't feel like coming up with it while I'm recording a video. Yeah, that's a nice sound. The dry one that's nice. I like it. So yeah, not a lot of controls on that chorus, but definitely, well, actually voice controls. Oh wow, there is a lot. You can go pretty wild with this. I'm actually very intrigued and also very, very daunted by how I'm going to make this UI work, because I do like this chorus. I do want it on this little drum machine. So again, thanks to the folks on the forum. I really appreciate the responses. Again, it's in this current situation we're in at the time of production on this. Meeting new people is wonderful, and while trying to up skills, it feels great to have support from people who have experience. I very much appreciate it. And I very much appreciate the sound of this drum machine, even though it's not perfect. Again, a flawed gem definitely has its place. All right, thanks for watching.